Okay, so root 2, quotient property of square roots, okay, is, anybody want to guess what root 2 is? Because root 1 was a square root of ab is equal to square root of a times square root of b. When I say quotient property, anybody? The other one was product property, so this was... yes?
So we got division like if they divide each other?
Yes, very good. So if I have square root of a over b, guess what this equals to? Oh, sorry. There you go. If I have square root of a over b, guess what this equals to? Yeah?
Square root of a over square root of b.
Exactly. It simply is square root of a over square root of b, just as you expected. Okay? So yes, square root of a over square root of b is what this becomes. And knowing this, we could do some simplification. And also it turns out that when you are simplifying these square roots,
Can't the square roots cancel out?
what do you mean?
Like, it's like square root on top and square root on bottom.
Hmm?
Can't they cancel out then?
No.
No?
No.
Because I thought Mr. Byer told us that last week.
No, I think you're kind of getting confused with something else. But let's see if you agree with what I'm saying. So whenever we have something like this, you have to always simplify. And when the way to simplify is, turns out that you cannot have square root on the denominator. Do you think it's okay to have square roots on the numerator? Yeah. But it turns out you cannot have square roots on the denominator. So we'll deal with that later. Not today, I don't think, but later. So let's take a look at example 3. So we need to always simplify this. And what I'm saying here is, if you have some fraction, do you think you should always simplify that fraction before you try anything else? Yes? Yes, okay. So if I have 64 over 169, does anything go into 64 and 169 that you could simplify before beginning? No, I don't think anything goes in, does it? Okay, so then how should we simplify this example 3? Yeah.
Are they both perfect squares?
Yeah, they're both, so numerator and the denominators are both perfect squares. Very good. And if you didn't see that, you could do a factor tray, right? And you will see. So yes, what is it? 64 is a perfect square of what number? 8. What about 169? Yes, 13. So it turns out it is simply, so by the way, can I forget about this negative outside? No, okay, you can't do that. So you get negative of square root of 64 over 169, because it becomes negative 8 over 13, because, again, you just said it, square root of 64 is really 8 squared, 169 is 13 squared, so therefore it just simply becomes negative 8 over 13. Pretty easy? Okay. You get the idea? Yeah, question?
I thought you said there could be no square root on the...
Yeah, so now we don't have any square roots in the denominator. It became, you had square root of 169, now it just simply became 13.
Okay.
But then the problem is, what if the denominator is not perfect square? What are you going to do, you see? So if that happens, we'll talk about that next time, how to simplify. Okay? Yeah, you cannot have square roots on the denominator, then that's not really simplified. Okay? Good. Let's move on. Plus or minus, or positive or negative, square root of 576 over 1,225. By the way, before we begin, what does that positive or negative sign in front of it mean? Yes, Maya? That's right. Guess how many numbers this represents? 2 of them. Okay, so this is a kind of a shortcut of writing 2 numbers that happens to be opposite of each other. Right, this is positive square root of 576 over 1,225. Okay, also it represents negative of square root of that whole fraction. Okay, so sometimes when the 2 numbers are same except their sign, they just write it this way. Anyway, is there a way to simplify this?
Yeah,
Yeah, so we should try to see whether or not 576 and 225 are perfect squares. Correct? So how are we going to do this, Ben?
We have to just put positive and negative on
what about these two numbers? What about the radicand? What are you gonna do with the radicand? Don't you try to? Don't we have to see whether or not they're perfect squares? So we have to do what, class? First, yeah, we have to. Yeah, first we separate them, then we do a factor tree. So go ahead, everybody. I'll give you some time. Go ahead, everybody, do a factor tree for 576 and 1,225. Go ahead, I'll give you time. Didn't we do 1,225 before already? No. Okay, go ahead. So when I did my factor tree, I mean, it doesn't have to start with this way, but I got for 576. By the way, I circle my, since it's a factor tree, I circle my leaves. You know why they're called leaves? Because it doesn't go any further. Yeah, these are leaves. You know, it's a tree. Anyway, so I got 2, 2, 2, 2, 2. How many 2s do I have? 1, 2, 3, 4, 5, 6 of them. And then don't forget the 2 3s I get. And then I get 5, 5, 7, 7, 4, 2, 2, 20, 2,100, 1,225. So, what does then, how should I write this as? Square root of 2 squared, square root of 2 squared, square root of 2 squared, and square root of 3 squared over square root of 5 squared times square root of 7 squared. Does that make sense? Yeah, question?
Put 9 over times 60.
Yeah, if you left it as 9 and so, yeah.
No, but no, but I put 3 over 3 and there's 3.
Yeah, so it doesn't really matter. At the end, you should have gotten something like this. Because, you know, you don't always have to start with 2 times 2 to 8, right? It could have been something else, right? 9 times, like you said, 9 times something. Yeah, but at the very end, the number of leaves you get should be all same, right? Okay, so you should have gotten, right? 2 square root of 2 square, square root of 2 square, and so forth. So I get 2 times 2 times 2 times 3 over 5 times 7. How many people got plus or minus 24 over 35? Raise your hand. Okay, does this make sense? How many number does this represent? 2. Positive 24 over 35. And what else? Negative 24 over 35. You guys understand? Any questions? We good? Okay. Good.